Hello, everybody. So today we will be covering section 6.8, which goes into imaginary numbers. So let's talk about the notes first. So we have the definition of the imaginary number I. So I is equal to the square root of -1. So keep note from the definition of I, it follows that I squared is equal to -1. So what you do is you just square both sides, and we know the square root squared is the radicand itself, so it's -1, and then just I squared. Right, so that is I. And then now we're going to go on the definition of the square root of -b when b is greater than 0. So if b is a positive real number, then the square root of -b is equal to I negative b. So why is that? So if going over here, -b, that can be rewritten as -1 times b if we use right, so -1 times b, and so we know the square root of -1 is I, so this is just I square root of b. Okay. So the definition of a complex number is in the form a plus bi. A and b are real numbers, and I is equal to the square root of 1. So a couple of notes, if b is equal to 0, then the complex number a plus bi is a real number. So all the numbers that we've been dealing with, like 3, 2.5, I don't know, 100, -2, all of them have plus 0i at the end of it, right? We just don't talk about it. Right, so if b is not equal to 0, then we say a plus bi is an imaginary number, right? So even if b is not equal to 0, so if we have so a plus bi, so if we had 1 plus 3i, this is a complex number, even if it was just 3i. So if a was 0, this is still a complex number, right? And then let's see. So a plus bi, that is called the standard form. And then the quantities a and b are called the real and imaginary parts, respectively. So a is the real part of the complex number, and then b, the bi, is the imaginary part. So b is the imaginary part. And lastly, for complex numbers, a minus bi and a plus bi are called complex conjugates. Always keep in mind when you do complex numbers, and you'll see why sometime later, it has to be in standard form. It cannot be bi plus a, right? This is not right. It always has to be in the form a plus bi, and then the conjugate is always a minus bi, right? It's not like the radicals where it doesn't matter which order it's in. For complex, it does matter. And then down here, I took a figure from the book, and it just talks about all of the numbers. So it just little groups. So every number, like real and imaginary numbers, they're all considered complex numbers. But real numbers are only when b is equal to 0. And then for the real numbers, we talked about it first day of class. And we talked about little subsets, like how natural numbers are smaller than whole numbers, which is smaller than integers, and then the real numbers are broken up into rational and irrational numbers. So for rational numbers, all rational numbers also include integers, whole numbers, and natural numbers. So if you guys have any questions about this, you can ask me. So now let's get started with our examples. So starting with section 1. Section 1, we just want to use I to rewrite square roots of negative numbers. So example, we have the square root of -18. So this is using that definition of -b. So the square root of -b is equal to I square root of b, as long as b is real, and 18 is a real number. So this becomes I times 18. Right? So we want to simplify as much as possible. So for 18, it is not simplified. Why? Because there is a perfect square root that goes into there. What is it? It is 9. So 9 times 2 is equal to 18. And when we simplify that, when we use the multiplication property, this becomes 3i times the square root of 2. Right. Maybe I did that a little too fast. So let me add another step here. So this is I, and then for the multiplication property, because 9 and 2 are both real numbers, and if I took the square root of them, I would get real numbers. So I can do this, right, and that's how I get to the bottom. Right.